only this one. That is a greedy, which means in terms of algorithm, greedy algorithm focus on local maxima, local optima. It doesn't consider overall, which means once this one is divided, never mixed. Okay? The descendant of this one only consider part of this, never going back, because you can see sometimes if you can consider this of the data that fit to this may be better. However, because of the classifying, the using the age never be mixed. This is a greedy algorithm. Not all the classification is greedy algorithm, but decision tree is based on the greedy algorithm. And also divide and conquer. It's a top-down approach. Divide and conquer means, so first divide and apply. It's kind of recursive approach. Like this one. Then another limitation of one of the limitation of the using decision tree is it works well with the categorical data. Think about the numerical data or continuous data, like the height. So everyone wants the 5 feet, the 10 inches, and 5 feet, 11 inch, or the 4. It's very hard to cut, or the class can we consider 4 inches too detailed. Okay, we cannot find sometimes the rule if that is too precise. Okay, so mostly it works very well with the categorical data. Okay, but there is a way to handle continuous data. We will see later. Okay, and the problem is how to find such a purity or impurity of the data that can be understood as information gain. Information gain. Think about the. Oops, it's very hard. You don't have to pay attention to this one. It's a very straightforward. If you take a take a look at the textbook, so you can find this algorithm. But it's just as straightforward. It doesn't mention how we can select the attribute yet here. Okay, it's just a simple algorithm. This one shows the different types of the attribute first. So as we have seen at the beginning of the this class, we have seen the different types of the data. Binary data, yes, it's good. And nominal data, ordinal data, but continuous data getting harder. And also, how can we split it to the children node? Okay, so it's a two-way split, not always. Sometimes the three-way and multi-ways. Okay, so for example, the body temperature is not S1, it's a warm-blooded or cold-blooded. It's a two-way, the binary attribute. But we have the car type, for example, family, sports, and the luxurious car. Yes, and it can be binary split. We can intentionally make this one sports luxury versus family, sports family versus luxury, and so on. So as a designer of or a modeler of this one, such a model construction, so you guys need to decide how to handle attribute. Also multi-way split. What about the continuous data? That's the problem. So most popular one is something threshold value. You assign the less than and bigger than. Okay, how can you find? Sometimes you can use the middle value or average. Or if you have domain knowledge, you can add your domain knowledge to split into two. Or sometimes this is a text bracket, right? Kind of text bracket. So if there exists such a knowledge, so in terms of the text, so there exists a text bracket. Okay, I cannot remember 75K to the 150K. Am I correct? I'm not sure, but if you can find like the customer level, if you have the based on the total amount of the balance. So if your company or the domain has such a thing, you can apply. Otherwise, you guys need to decide using average or something medium value. Okay. So this is a key part of the classification. First, how to measure such a purity or impurity of the data. So we are going to adapt idea of entropy using information theory. What is the entropy?
Again.
Gain?
For example, in that view here, when you said you were gonna go with age, if you go to the students, it's better, right? Because you have more purity.
What is the energy? In general, not the information retrieval or information theory. What is the energy? Energy means
Power.
it's a very active and something happen. Is it stable? No. High energy means it's an unstable condition. Okay? Like the nuclear weapon. Nuclear weapon is caused by the very active, what is that? I'm not very familiar with that part, but anyway, it's the stable, then the H or the helium or whatever, right? So it's an unstable condition. So because of that, it can make the huge energy and explode, right? So high energy means the unstable condition. In the data, if you have something only 1, 1, 1, 1, is it stable or unstable? It's a stable condition. It's a pure. In terms of energy, it's a low energy. So how can we measure that? That is called entropy. Okay? So lower energy is a stable, is a purity. Higher energy means it's a impurity data. So it's a high energy. Think about the tossing the coin. Tossing the coin in terms of probability. So it's always half and half. Okay? So it is stable. So this is the PDF, not PDF, it's a probability of the tossing the coin. It's the highest energy is the half and half. Am I correct? It's a point. Yeah. Highest energy. So tossing the coin is a half and half. That means what? Confused. Highest energy. The half and half. Tossing the coin should be stable. So it's a less energy. And if the coin is distorted, then it will be the random rotating and distance varying, higher entropy, higher uncertainty. So higher entropy, higher energy means, oh yes, right.
Yeah, I heard
right.
Yeah.
So that's correct. So if the coin is the half and half, there's a less energy, less entropy, is a lower uncertainty. It's a certain. Okay? Uncertainty is low, which means we are the guarantee half and half. However, if we toss this kind of thing, it's not half the asymmetric the shape. It's not half and half. Sometimes 60% or 40%. It's a fluctuated. At that time, it has a higher energy. That means it's a high uncertainty, impurity data. So we are going to adapt that idea in the classification. That is this one. This is nothing but probability. Okay, that happens. So in terms of this data, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Among 6 is 2 of them are no. That means it's a third.
No.
2 out of 6 is a 33%. Okay, 33% is a probability for each. So how many class? So 33% is 1 out of 3. Then this one is applied to logarithm because it's a maximum. The 1, it can be bitwise. It can be represented by the bit by bit. So we apply the logarithm based on 2. Okay? So then this one is a sum up with for each class, like the yes and no. Okay? Then because of this logarithm graph is a minus, then it can form this kind of the shape. Okay? So this is called the entropy for that attribute. So we try to find, okay? Then the conditional entropy is for specific the attribute. What is the entropy? So this is the expected information total energy, total entropy in this D, all entire data. So that is just the sum of the probability for each class. In this case, the sum of 1 over 3 times the logarithm 1 over 3 plus the 2 over 3 times the logarithm 2 over 3. Okay, sum up and minus because it's logarithm. Okay, so minus doesn't mean opposite, it's a logarithm. Okay, then because it's less than 1, the log, in the log, the probability is always less than 1. Okay, if you put the minus, it will be the positive value. Then that is the total entropy expected information. Then the information needed means is the normalized for each the class. Okay, this is the 1 out of 2 out of 6, and what is the, if we consider attribute A, the using A, okay, if we select the first, this one, the student, this one is the first this, the expected information. So from we select the attribute A, okay, then for that attribute A, we compute the total information. Then what is the portion of this one is when we classify this A, the student is 2, the split. Okay, binary split for each the split, what is the portion of that, and that is a sum of, that is information, the impurity, or in case of A. So what we want is we try to minimize the purity one. That means the less number. So information gain means total, from the total minus this one. So we try to find among the A1, A2, A3, n number of attributes, we try to find the attribute that can maximize this. In other words, we try to find the attribute that can make the higher purity. Okay, clearly divide the class. Okay, so that is the meaning of the information gain. Actually, this idea is not from the data mining technique, it's information theory. Information theory actually borrowed the idea from the mechanics, energy, or whatever. Okay, so that is the information. How can we use? What time is it? Oh, yeah, a little bit more time. So let's see the example of the information gain. So this is the same sample data. So we have 14 the cases. So this is the buying computer or the not buying computer, buying computer class. So we try to classify. We try to find the rule, model or classifier, whether wanna buy computer using the data. Okay. So how can we find first the total information is information of the total. So how can we compute? So 9 of them are yes, 5 of them are no. So we can compute easily. Okay. Sum of for each class. So 9 over 14 and 9 over 14 logarithm 2. Then it's 0.94. What? Extreme case is all of them are yes and nothing no. What happened? This is 1. This is 1. Okay. Log 1 means 0. So this is a 0. So lowest energy, entropy, means sustainable. You don't have to classify. Okay? Extreme case is all of these are different number. Okay? That means it's a small number, 1 over 14, 1 over 14. Then, what is the 1 over logarithm of 1 over small number? It's a minus something. That minus will be positive because of this one. It's a huge number. Okay? So if that is not purity data class, which means all different value, different class, it will be very high information. Not information, energy, entropy, which means it's a huge. So that is total. So we try to find the attribute that can reduce a little bit. Okay? Which means the attribute is pure, that information is also small. Smallest information needed attribute. That's our goal to find. Smallest one. So we try to test for each attribute. Age, income, student, credit rating. For example, age. So this is the portion of this one. So how many of them? 5. For the less than 30, how many less than 30? 1, 2, 3, 4, 5. 5 case. For the 5 case, that is a 5 over 14. So we try to find the information energy. Okay, for that 5. 2 versus 3. So we can apply the same, the expected information, the equation, this one. So then also 4 over 14 is 32, 40. And the 5 over 14 is the over 40. Then we can compute the information, expected information using the previous the equation, that is the 0.694. Then what is the information gain in case of the age? That is the subtract. So 0.94 minus 69. That is the 246, which means, so after, if you classify using the age, the information gain because of the age is 246. So we try to find the highest value of this one, which means minimum value of the information age. Minimum means the lower energy is a high purity. Can you understand why? So we are going to use the energy. So this is a common mistake. High energy means impure data because it's not stable. So usually I'm thinking the extreme case. All yes or all no. All yes means that's a stable, it's a 0. Okay? We don't have to. But the huge number is fluctuated a lot. The information are mixed. So we cannot use that one. So in case of the income is it provide the gain, which means if we compute the info gain, the info income, it is the very high value because that is impurity data. Okay? So we can select the age for the first attribute to classify. Okay? So that is the ID3, the decision tree, using information gain.
Professor,
Yes.
so in both cases, it's not preferred to use that. Even
Which
in,
one?
The classifier.
Classifier.
Yeah, in both cases, which are the high energy and low.
So we
Because
have a high.
if we have stable,
Hmm?
we'll get no benefits from that.
Yes.
Am I right?
Hmm?
And with
I don't get it exactly. So let's
we have two cases. That's
two cases.
Yeah.
Okay.
In both cases, we're not prepared to use the classifier that one.
Which means extremely high,
Extremely high or,
right?
or
Extremely
low.
low. Yes, because the extremely low, the entropy means we don't have
Yeah, we
to.
don't have to.
But extremely high case may not be possible to classify, right?
Yeah.
Okay. Yeah, that makes sense. Okay, so what if we have the continuous value, which means the number, the continuous number? At the time, we need to decide the best split point. So if you have the domain knowledge, like the credit, the tax bracket, or the consumer, the level, or whatever, we can use. Otherwise, we can most common, the split point is the average. Okay, the middle value, cardinal half. Okay. So we will see the next one is we are going to address something problem of the such information gain. So that is the gain ratio, then followed by the Gini index, which is very popular in the decision tree after a short break. Okay. So we are going to have a 5-minute break.